Hey guys, welcome to the second video of the playlist Algorithms in JavaScript. So in this video, we'll be talking about two pointers algorithm. So you may or may not have heard about this algorithm, but it is a pretty popular algorithm and a lot of people like software engineers, problem solvers, competitive programmers may be using this algorithm in their day-to-day life and day-to-day problems, right? So two pointers technique is kind of necessity in SD toolkit, right? So and you know, especially when it comes to technical interviews, this algorithm comes really handy, right, in solving problems in a really optimal way, right? So in this video we'll cover the basics of the two pointers technique, two pointers algorithm, and how to use it, right? So let's try to find out what is two pointers technique. So basically there are two variants of these technique. First, I'll try to explain you before all of these. I'll try to explain you before all of these, like what actually is the two pointer technique. So let's imagine, what do we understand by two pointers? Two pointers. What do we understand by that? So it is clearly indicating we are talking about two things, right? And pointers, you can take anything. Pointers means two locations, right? It means two locations. Two locations. We are pointing to something, right? So there are two pointers. So we can put them anywhere. And we will try to solve a given problem with these locations, with these pointers, these indicators, right? So it could be like you say we have an array 1 2 3 4, right? There is pointer 1, this is pointer 2. We can solve this problem given a problem statement with the help of these two pointers, right? So what is the pattern? Pattern? So the name two pointers, it itself tells what it is. Like, it is what it sounds, two pointers. So we use the two pointer to solve a problem involving like a lot of problem involving indices like arrays, strings. We'll be using in the two pointer technique a lot. So basically, if you want to know what are pointers, so basically pointers in programming are reference objects. Like what are reference objects? Reference objects which refer to something. Means it pointers contains address. Of the variables. So basically in programming, pointers denote location. So what is an address? Address is a location of some variables they point to, right? Cool. Now so address is this address lives in the memory, right? In most of the case in RAM or any other type of memory, right? So let's discuss, right? There are two types of pointers, right? One is, it's better saying like this way, like there are two variants of two pointers algorithm, a slow and fast and start and end. So in a lot of cases we take two pointers and we move one pointer faster than the other pointer, right? We move the other one slower than the other one, right? One pointer moves faster than the other one. And the second variant is we put one pointer at the start, other pointer at the end, and we try to solve a problem. So these are the two variants of the two pointer technique. So so you would ask me like, yeah, you would ask me like, hey, when do we use this, right? So I would tell you to use two pointer technique in mostly in case of arrays slash lists. You call arrays lists in Python, right? Okay. Or in other ways where you have to compare things. If you have to compare things, use the two pointer technique, right? Okay. Now there are a lot of patterns in the two pointer technique, right? And there are a lot of questions. There are a lot of questions which could be solved with this two pointer technique, right? So I already told you there are two variants of the two pointer technique. So one variant is the one pointer starting from the beginning and the other starting from the end, and we move those pointers until they meet, or until they meet, or you can say the exit condition might be the start should not be greater than end, right? The start index should not be greater than end, right? And the other one is moving at a slow pace and other one is moving at a fast pace, right? And twice the speed. Basically slow and fast case, fast moves the twice the speed, right? Okay. So right now let's there are a lot of questions, different types of questions which come under this which could be solved with this algorithm two pointer technique, but I'll talk about two questions mainly, right? And rotating an array and removing the nth node from the end of linked list, right? So yeah, so now we know what are two pointers. So let's talk about questions for two pointers. So we'll talk about a question which is rotating an array right, by k steps. So what is the question? So we would be having an array, let's say 1 2 3 4, and we are asked to rotate it by n steps. N can be 1 2 even 0 3 4. That doesn't mean anything, but yeah, 1 2 3 4. Okay, so let's talk about the question. So let's say we have an array which is 1 2 3 4. So let's try to find out some pattern. Let's say we want to rotate the array by 2 steps. So what would be the steps? First what we would do is we'll move the 4 to the first 1 2 3. So this 1 2 3 would shift back to right. Next step, the second step, we would again move 3 to the first with now 1 2. So you see what is happening, right? We are rotating an array, then we are rotating an array, right? And this semi rotation, then this one completes the rotation. Things are getting rotated to the right. This 1 2 will complete the rotation. So this is the result we are getting. So you see some behavior. Can we reduce these steps by 2 pointers? Yeah, we can. So the general thing that I saw is, let's see what we can do is, let's break this array into two parts. So our goal is to start the rotation from the right side, right part. So our goal is to start the rotation from the right part, right? So why don't we right part? And in like, if you want to see this in another way, you see the answer, right? You see the answer. So what you're seeing is our array is this, and what is happening, and we have to rotate it by 2 steps. So last 2 elements you're seeing, they're the first 2 elements in the reversed manner, and the remaining elements are just put in the same way at the end, right? So what we can do is, why not just reverse the array, which is very efficient and like very memory and time efficient also, and just reverse the first k elements, right? Reverse the first k elements and last k elements. That would work, right? So if we reverse the we reverse the array, and if we reverse the first k elements, which is 3, 4, and k is 2, and reverse the last k elements, which is 2, 1, which is 1, 2, so we got the answer, we got the result. So this is efficient. So what we have done is, we have reversed the first k elements taking 2 pointers. This k elements can be k times. If k is 100, these elements can be 100 elements, right, in 100 numbers. So we can take 2 pointers, pointer 1, pointer 2, we can reverse this, and we can reverse this by using the swapping technique. So we have 2 pointers, pointer 1, pointer 2, we can take a temp, we can place pointer 1 in temp, value at pointer, value at p1 in temp, and we can assign the p1. Okay, we can take the value of p1, store the value of p1 in temp, right? And now our p2 will be at p1 and p1 will be at p2. So p2 will be p1, right? Yeah, p1 will be p2, right? And our p1 will be at p2. So we can take p1 and p2 2 pointers, which are sitting at the start and the end. We are using the first variant, and we can swap these first k elements and last k elements in order to reverse them, right? So, and same for the case of reversing the whole array, right? So what we can do is, we can take p1 in temp, value at p1 in temp, and we can now assign value of p2 at p1, and now we can assign the p2 temp, right? Let's see how this is implemented in the code, right? So you see, what we have done is, we are just doing the modulo operator. So this is a very important step, and this is been put here to save time and complexity. I'll tell you how. So let's say we have 1, 2, 3, 4. If you have to rotate this array by 4 times, you have to do the operation 4 times, rotating operation 4 times, step by step. And what you'll get the same array. You can try doing that, get the same array. So why, if the length is equals to k, array length is equals to k, then why to rotate the array? Even if we know, if this is the condition, then the array would be same. Why to rotate the array even? So we will do is, we'll try to divide this k by our nums, our array dot length, to know if this is 0, because this is a modulo operator. Remainder gives remainder, this gives remainder, so this would give 0. We'll know that we don't need to do multiple operation to reverse the array, to reverse the first element, reverse the last element. We know that our array would be same, right, even after these operations. So we don't need to do any operation, 0. first k elements, 0 last k elements, right? We just have to get the array. We just need that same array, right? So this is why we did this, right? Then our first operation that I already told you, just reverse the whole array, then reverse the first k elements. First k elements are 0. We are starting from 0. That's why we are reducing the k by 1, right? And this is a reusable function. We are every time we are calling the reverse array. This is a 3-step process, right? And this k is 4, right? This is a 3-step process, and let's just see reverse array. So what reverse array is doing is taking the array as an input, the first pointer, second pointer, start and end. And this is an obvious condition, the exit condition for loop. The start should be less than end. It's clear. It's obvious that the start should be less than end, because they cannot meet at the same point. Okay, the start should be less than end. So we are doing swapping. We are incrementing the start and decrementing the end, and so that they can come closer and be at a meeting point and satisfy this exit condition for while loop. Now our array will be swapped here in this function. So our array will be reversed. Now we will reverse the first k elements, right? Now after that we will reverse the last k elements, as we have talked in that explanation I gave, right? Now when the last k elements are reversed, we have a result, right? We have a result, as I already told you. So let's say I told you a case and where k is equal to the nums.length or the array length. So when is k is 4, you see we just have to reverse our array. This function will not, even if it is called, nothing will happen, because this while loop condition will not be satisfied, because this is 0, start is 0, but end will be -1, and this will not go into the while loop, because 0 is not less than -1, 0 is greater than -1, right? So our array will be reversed, then it will again be reversed, and we have a result, the same array. Now let's see it in action. We have two console logs, 1 2 3 4, rotate by 4, -1 -100, 399, rotate by 2. So let's see what happens. So rotate array, you see we're getting 1 2 3 4 because we are rotating the array by 4 steps and our array length is 4, right? So we're getting the same result. Now in this condition we want to rotate by 2 steps. What should be the result? Result should be 399 -1 -100, and this is what we are getting, 399 -1 -100. If we reverse the array, we rotate the first, we reverse the first elements, right? And we reverse the last k elements. So that is it. Hope you have liked the video. Hope you have learned something. Please like, subscribe for more videos, because a lot of more videos on algorithms in JavaScript would be coming later. So stay tuned and keep watching and keep learning. Thank you so much.